Welcome to the Deep Dive, where we take that fire hose of information, your specific source materials, and distill it all down to the essential, fascinating insights you need to know. Today, we are strapping in for a high-speed look straight into the very near future, specifically the year 2026, and what's being projected as a tectonic shift in the world of artificial intelligence.
Yeah, it's not often that you see a forecast from inside the industry declare, a definitive end to one era and the immediate urgent beginning of another. But that is precisely the conviction that's running through the analysis we're looking at today. This isn't just about faster chips or better algorithms. It's a fundamental redefinition of what AI is built for and what it's intended to do.
Okay, let's unpack this then. Our source today is an AI News Digest, and it's dated December 13, 2025. It's incredibly valuable because it doesn't just look backward. It really captures that moment where the AI community decisively pivoted its focus and positioned the next major industrial priority right as the year was wrapping up. So the mission for us, and for you, our listener, is to quickly get a thorough understanding of the specific shifts, both technological and, philosophical, that are driving this new wave. And we're zeroing in on two new priorities, operational agency and radical energy efficiency.
Right, and if the last few years have been dominated by the spectacular, often experimental successes of generative AI, the tools that create stunning text, perfect images, novel code, all of that, the forecast we're seeing suggests 2026 is the year that technology matures, gets off the drawing board, and fully commits to operational work. We're moving from AI as this sort of reactive generative assistant to AI as an independent, proactive, operational actor within core industry.
That contrast is absolutely critical. So why are we moving past the experimental phase? I mean, generative AI has dominated every single headline. It's captured the public imagination. We spent years chasing model size and fluency. Why is just synthesizing information and creating content suddenly not the most exciting frontier anymore?
Well, the dominant generative models, while they've achieved this unprecedented fluency, they fundamentally operate on information processing and content output. They're amazing tools for creativity, for summarization, for assistance. They react brilliantly to a human prompt.
Right.
But two major forces are now converging. First, the market has sort of reached a point of saturation for basic content generation. And second, the technical costs of pursuing even more fluency in the old way, have just become economically prohibitive. So the forecast suggests the market is now demanding utility, reliability, and most importantly, independent action at scale.
So this shift isn't incremental. It's a fundamental redefinition of AI's role, moving from just handling data to actually taking independent verified action in physical and industrial processes.
Precisely. The moment we ask an AI to manage a complex supply chain or, say, run a chemical processing plant, the criteria for success immediately changes. It's no longer, does the output sound good?
Right.
It becomes, did the action produce the correct physical result safely and efficiently? And that is the core driver of the 2026 shift.
Okay, so let's nail down that timeline. The source is very specific here. It anticipates this major shift taking hold definitively in 2026. Now, that doesn't mean the technology is invented in 2026.
No.
But that the commercial focus, the infrastructural deployment, the primary research investment, it's all aligning for this pivot right now.
Exactly. When you look back at the last few years, the major characteristic of that experimental generative AI phase was defined by two primary metrics. First was the pursuit of ever better, content generation quality, text, imagery, whatever. And the second was the aggressive, almost dogmatic scaling of model parameters.
We absolutely need to linger on that, our model parameters, for a second, because that really was the entire competitive landscape. If you weren't talking about having 1 billion more parameters than your competitor, you just weren't in the race.
Parameter count became the shorthand for sophistication, for success. The general wisdom, what we call scaling laws, basically dictated that if you wanted a smarter model, you had to feed it more data and make it geometrically bigger.
More is more.
More is more. More parameters meant greater complexity, the ability to store more subtle relationships in the data, and so you got more capable summarization or generation. And this approach led to those massive, groundbreaking models we're all familiar with, but it created models that were immensely expensive to train. We're talking capital expenditure in the billions, and hugely resource intensive to run for every single query.
And all of that was focused on intellectual or creative output. But the source signals the spotlight is moving away from this. It's not that we won't use generative AI, but the bleeding edge, where all the R&D and investment is going, That's shifted. We're sort of closing the book on the era where parameter count was the ultimate metric of success.
And the reason we're closing that book is the stark reality of diminishing returns.
Okay.
So let's define what that looked like in late 2025. Developers found that increasing model size by, say, 50% might only yield a 2 or 3% increase in linguistic fluency or creative quality.
A tiny gain.
A tiny gain. Meanwhile, the training costs and, critically, the latency and the energy consumption, they just shot up disproportionately. The gains in that abstract capability no longer justified the escalating economic and, frankly, environmental costs.
So we hit a point where the models were just big enough. They could handle most commercial content tasks well enough, writing a summary, drafting an email, creating stock art.
Yeah.
The extra cost to get that last little sliver of perfection just wasn't worth the operational expense of running a giant model 24/7.
That's the conclusion of the experimental phase right there. First, the core task-generating high-quality content, it's considered sufficiently solved for most high-volume commercial applications. And second, the cost of scaling those parameters further is economically unsustainable when you're talking about industrial deployment. That kind of deployment requires reliability and efficiency over sheer abstract scale. So the focus shifts from making a model smarter in an abstract sense to making it more competent and reliable in an operational one.
Which brings us right into the new era, the rise of autonomous systems. And this is a dramatic change in identity for AI. It's moving from a digital collaborator or a tool you prompt to an independent operator that's managing a process.
It signals that AI is ready for that deeper operational integration. It's moving out of the R&D sandbox and into the messy, complex reality of industrial execution. It's a sign of maturity in the technology. We're dealing with systems that go way beyond just summarizing or generating content. They're engineered for execution.
So if we detail the core paradigm shift described in the source, it's this engineering and philosophical pivot. The shift is from the previous emphasis on model parameters, the size and scale, to prioritizing two completely different and sometimes opposing areas, agency and energy efficiency.
And that's the critical trade-off that defines 2026. Agency addresses the capability, the ability to act independently and achieve long-term goals. Energy efficiency addresses the sustainability and the economics of that action.
Right.
The industry realized that building a billion-parameter agent that costs a fortune to run every second is useless for industrial deployment. You simply cannot integrate autonomous AI deeply into, say, a smart grid or a large-scale manufacturing environment if it consumes the power of a small city just to run one task cycle.
It's a difference between building, I don't know, a concept car with 1,000 horsepower versus building a fleet of reliable, cost-effective industrial vehicles that can haul freight 24/7 without breaking down or emptying the gas tank every hour.
That's a perfect analogy.
The focus has moved from this abstract, often clumsy intelligence to hyper-optimized functional competence.
Precisely. These autonomous systems have to be designed for persistent, high-reliability performance in complex, dynamic, and constrained industrial environments, not just vast, abstract data spaces. And that requires a fundamentally different engineering approach than just optimizing for content quality. It means we have to dive into the architecture of the AI itself.
I want to pause on that point because some listeners might be asking, wait a minute, doesn't an autonomous agent still need to generate content? If it's managing a factory, it might need to generate a purchase order or a diagnostic report. How do we draw that line between a generative action and an operational one?
That's a great question, and it really speaks to the nuance of this shift. The distinction is between end product generation and operational synthesis. A pure generative AI's primary output is the content, the essay, the image. An autonomous agent, on the other hand, uses generation internally as a means to an operational end. It might generate a sequence of actions, or generate a segment of code to fix a bug, or generate a warning message. The focus isn't on the quality of the generated text, but on the success of the physical or operational goal that the text facilitates. The primary metric is the success of the action, not the elegance of the content.
That makes the shift much clearer. The era of focusing primarily on how much content AI can synthesize is giving way to the era of how effectively, reliably, and efficiently AI can act. Okay, let's dive deep into the first of those two new core priorities, agency. Now, this is a term that's loaded with all sorts of philosophical meaning, but in the context of this 2026 industrial forecast, we need a technical definition. What exactly is agency, and how is it fundamentally different from existing AI applications we already use, like, high-end smart assistants or even workflow automation tools?
This is really the transition from reactive technology to proactive, persistent technology. As you said, the old generative models required constant human prompting to steer them. The source provides a definition of agency that hinges on true independence. Autonomous systems will act with a level of autonomy that allows them to be truly self-sufficient and capable of independent action toward a goal.
That distinction, self-sufficient action, is crucial. Let's break down the architectural requirements for that. When we talk about a complex chatbot, it executes a single defined task. Prompt comes in, output goes out, then it sort of forgets the context and waits for the next prompt. What architecture does a truly agentic system require?
Well, to achieve agency, the AI needs a layered structure that looks very different from a simple large language model, an LLM. You're moving from a single transformer model to an integrated autonomous agent architecture. And this structure typically includes at least 4 core components, all functioning in a continuous loop. First, you have perception and memory. The system has to continuously absorb real-time data from its environment sensors, databases, other systems, and maintain a persistent structured memory of past actions and future goals. Then there's the planner, or reasoner. This component takes the high-level goal, something like increase factory throughput by 15% this quarter, and it breaks it down into actionable sequential steps. It generates an internal operational plan.
So it's the strategist.
It's the strategist. Then you have the executor. This component takes those planned steps and translates them into physical or digital commands, adjusting machinery, reallocating resources, opening tickets, sending emails.
The doer.
The doer. And finally, and this is crucial, you have the monitor or evaluator. This component is constantly measuring the effect of the executed actions against the original goal state. It detects discrepancies, errors, or environmental changes that mean the plan needs to be adjusted.
So it's a feedback loop.
It's a constant feedback loop.
Okay, so if I ask a generative AI to draft a press release about the new product, that's a single step executed by the executor part. But if I ask an autonomous system to launch the new product across all regions, that single instruction triggers the planner to draft a huge multi-step, multi-month strategy, which the monitor is constantly checking and adjusting. That's the independent action.
Exactly. Agency means going beyond a single command execution. It's completing a complex, multi-step goal in an environment with variables, unforeseen obstacles, and competing needs, all without constant human input. It's the persistence of the overall goal despite all that real-time friction.
And where are these complex operations designed to occur? The source specifies that these systems are designed to navigate and operate within complex industrial environments.
And this is where the engineering complexity just skyrockets. Complex industrial environments is a loaded term. It implies a setting that's far removed from clean APIs and digital server farms.
Right.
We're talking about manufacturing, logistics, energy, material science.
So let's break that down. What does that complexity actually entail? It means dealing with heterogeneity,
Yeah.
right? A mix of everything.
Absolutely. The data streams are not clean or standardized. You might have modern IoT sensors running alongside decades-old legacy equipment that's providing analog data. The system has to handle varied input formats, unreliable network latency, physical noise, interference.
All the messiness of the real world.
It's the challenge of real-world messy data. The AI has to filter that noise, validate sensor readings against historical trends, and figure out which piece of information is trustworthy enough to base $1 million decision on.
Which requires robust capabilities for real-time decision-making, fault detection, resource management. I mean, using the factory analogy.
Yeah.
If a specific machine overheats or a batch of raw material is found to be substandard, the autonomous agent can't just stop and wait for a human.
Correct. That's the true test of agency, the ability to handle a failure mode gracefully. The agent has to recognize the fault, immediately calculate alternative strategies, maybe diverting the batch to a secondary process or slowing the entire line, and then compensate using backup data and automatically log the issue for a human to review later. And all of this happens while maintaining the highest priority, which is to continue executing the primary mission. This is dynamic plan regeneration, and it's a core feature of 2026-era agency.
And the decision-making has to be lightning fast. Industrial processes run in real time, sometimes at microsecond scales. A delay of seconds in recalibrating a production line could mean millions in lost productivity or wasted materials or even safety hazards.
So the complexity demands rapid, independent problem solving.
And the goal, as the source points out, is for these systems to be integrated so deeply that they become, internal operational actors rather than external tools.
Exactly. Instead of using AI to get advice on how to run a factory, the AI becomes a major self-managing segment of the operational management team.
Okay, so if the system achieves this robust, persistent agency, what's the core practical payoff for the industries adopting this?
The source states it very clearly. This independent capability will allow AI to function with increased efficiency and dramatically reduced human intervention. That is the practical commercial payoff of achieving true agency.
That reduction in human intervention, that's the economic multiplier we keep talking about. If a human operator no longer needs to spend 80% of their day just monitoring dashboards for routine anomalies and can dedicate just 20% of their time to validating the AI's highest level strategic decisions or managing novel catastrophic failures, the productivity gains are transformative.
The human role shifts fundamentally. It goes from continuous monitoring and correction, which is prone to fatigue and slow response times, to high-level oversight and strategic guidance. The autonomous system handles the operational friction and the minute-by-minute decision-making required to meet that high-level objective. True agency minimizes the human in the loop during normal operating conditions.
Which maximizes throughput, consistency, and reduces errors.
Exactly.
But wait, doesn't achieving this level of agency with persistent memory, real-time planning, constant monitoring, doesn't that inherently require massive computational power? That seems to fly right in the face of the second priority, energy efficiency. Are we not just trading capability for sustainability here?
That is the essential conflict that the 2026 shift is designed to resolve. The industry learned through the generative phase that scaling the general purpose parameters exponentially led to bloated, inefficient systems. The breakthrough for 2026 is that developers are finding ways to build specialized, sparse architectures specifically designed for operational agency.
Oh,
So we're not using a model that was designed for abstract reasoning to run a factory. We are using a model that's hyper-optimized for dynamic control. And that leads us directly into the discussion of efficiency.
okay, so we've established that agency, the ability to act independently, is half of the new paradigm. But the forecast explicitly states the other core priority is extreme energy efficiency. The source elevates this to a new, required benchmark for success in industrial AI.
Yeah, and this is where the economics and the engineering intersect so critically. The source states the transition will set a new benchmark for energy-efficient AI solutions. And this isn't an environmental mandate, really. It's an economic one. It's what makes the technology commercially viable at scale.
Why is this so critical for industrial integration, especially after years where we just sort of accepted that bigger models meant bigger power bills?
The previous experimental phase focused on generating content. It prioritized performance regardless of energy cost. A model that runs once to answer a complex query or generate a unique asset, even if it uses kilowatts of power, is a high-peak, single-use expense. The operational expense, the OPEX, is tolerable because the task is discrete.
But the autonomous systems we just spent the last section discussing are fundamentally different. They're designed for continuous deployment.
Exactly. They are integrated into complex industrial environments. They require continuous observation, continuous calculation, continuous action, 24 hours a day, 7 days a week. The computational cost shifts from a high peak for one task to a persistent high-volume baseline. And if that baseline is based on the old parameter-heavy architecture, running that system autonomously and constantly would make the operational cost astronomical.
And that completely negates the economic benefit you get from the automation. The AI has to pay for itself through increased efficiency, and it can't do that if its power consumption is bankrupting the company.
That is the connection point. The need for efficiency is tied directly to the scale and duration of industrial operations. Operating at an autonomous level requires sustainable, lower-cost computing. This shift to efficiency is a commercial gatekeeper. It enables widespread industrial adoption. The AI has to be cheap to run, or it fails the economic test and it stays stuck in the lab.
So this suggests a massive engineering shift in how these operational models are actually built. We're moving from the philosophy of bigger is better to smaller, smarter, and infinitely more optimized for continuous operation. Can you elaborate on the technical solutions that are underpinning this massive efficiency gain that the source references?
Absolutely. When the source talks about setting a new benchmark for efficiency, it's implying advancements across 3 related areas, moving away from those generalized power-hungry architectures. First is model sparsity and pruning.
Okay.
Think of a traditional, massive generative model as a city full of roads, all of which have to be maintained and powered, even if traffic only uses one route at a time. Sparsity is the process of identifying and permanently removing or deactivating the connections, the roads within the neural network that contribute minimally to the task at hand. In this case, operational control.
So we're not running the entire massive brain for a simple task.
Mhm.
We are running a highly specialized, lightweight subnet of it.
Precisely. We're hiring a smaller, more specialized team to run the factory instead of bringing the entire workforce in every single day. The model only activates the necessary parts of its network for real-time control, which drastically reduces memory footprint and computational power draw during inference.
And that brings us to the second crucial concept, the difference between continuous inference and batch training.
Right. So training is the process of teaching the model. It happens infrequently, and it requires enormous, centralized batches of data and colossal compute power. That's the CapEx phase, the capital expenditure. Inference, by contrast, is the process of the AI actually using that knowledge in real time to make a decision. This is the 2004-7 OpEx phase. The goal of industrial AI is extremely fast, low latency, and continuous inference. Previous models were often optimized for massive batch training, which meant they were inefficient at the continuous deployment needed for industrial control.
So the 2026 systems are engineered explicitly to make that continuous inference step dramatically cheaper, faster, and less energy intensive. It's about making the model a lean, mean decision-making machine.
Which leads to the third area, specialized hardware. We're seeing a shift away from generalized GPUs, which are excellent for parallel batch training, toward custom-built ASICs or specialized inference engines. These hardware accelerators are physically designed to handle the specific computations needed for sparse, compressed operational models. And they offer power consumption reductions that the source suggests could be 40 to 50 times lower compared to running similar tasks on older generalized hardware.
Wow, a 40x reduction in inference power consumption compared to 2024 models. That's the specific metric that transforms the economics. This means the overall operational costs, once the system is deployed, become almost negligible compared to the labor savings and efficiency gains.
The benchmark is about achieving high agency while minimizing the thermodynamic cost of that intelligence. The convergence of agency, the independent action and efficiency, the cost reduction, that forms the powerful economic argument for this 2026 shift. It's the difference between a proof of concept and a commercially irresistible, inevitable product.
It seems then that the potential for these systems is just immense. The source highlights three major benefits stemming from this convergence: transforming industries by streamlining operations, enhancing productivity, and reducing operational costs.
Right. Streamlining operations is the direct result of that dynamic, independent action. And streamlining isn't just speeding up one step, it's optimizing the entire chain. An autonomous system can see bottlenecks, adjust resource allocation, and dynamically reprioritize workflows in real time across an entire industrial environment. It eliminates the systemic inefficiencies that are just inherent in human-managed, siloed processes.
And enhancing productivity follows immediately from that. Productivity is output per unit of input. If the AI is handling the friction, optimizing the flow 247, and operating with maximum energy efficiency, the unit of human capital or energy required just drops drastically, and the output rate becomes maximally consistent.
And reducing operational costs is the synthesis of both of those priorities. Efficiency slashes the energy cost per action. Agency slashes the labor cost and the error cost, faults, waste, downtime per action. When both systems are optimized using sparsity and specialized hardware, the overall cost structure of manufacturing, logistics, or energy management is just fundamentally altered. And that's what's driving this massive investment into the new paradigm.
The narrative here is so clear. The move from generative AI being a creative luxury to autonomous AI being an essential industrial infrastructure hinges entirely on the profitability enabled by this marriage of persistent capability and radical efficiency. So we've tracked the shift. Goodbye abstract scaling laws, hello operational agency, and engineered efficiency. And while the core application that's discussed in the source is industrial, the factory floor, the supply chain, the article makes sure to broaden the scope. It states that this transition will influence not only industrial sectors, but also our everyday lives.
And that's the historical pattern of any foundational technology when it matures. Once a system proves its reliability and its economic viability in the highest stakes, most complex settings, where failures cost millions and involve physical danger, it inevitably filters down into consumer and daily life applications. The technology gets cheaper, more robust, more accessible.
We might not see fully autonomous systems managing our appliances tomorrow, but the underlying technological breakthroughs are immediately applicable. The advancements in real-time, low-power decision-making that make factory automation possible will refine every subsequent piece of smart technology we use.
Absolutely. Think about smart infrastructure. An autonomous agent that's capable of dynamic fault detection and resource management in a noisy factory. That's the same core capability you need to optimize a city's public transit network in real time.
Right.
Adjusting train schedules based on localized demand and unexpected delays. It's the core of optimizing energy grids, predicting localized usage, and rerouting power with minimal loss. The foundational capabilities that were developed for industry, the agency and the efficiency, they become generalized capabilities for the smart world.
And that efficiency gain, the ability to run complex inference at a fraction of the power,
Yeah.
that's also crucial for consumer robotics and edge computing. Devices can become far smarter without constantly needing to phone home to a massive, distant, power-hungry server.
Exactly. That energy efficiency allows the agent to live entirely on the device, in a smart home hub, a personal drone, or maybe a healthcare monitoring device. That immediate local decision-making power is the link between the factory floor and the home.
The source also suggests that the autonomous capability is expected to lead to new innovations that we can only begin to imagine. This is that exciting, unpredictable phase of technology adoption. We're moving from AI accelerating our existing processes to AI discovering entirely new ones.
And that potential for unforeseen innovation stems directly from the definition of agency. If an autonomous agent can observe a complex system, form a hypothesis about optimization, design an experiment, execute that experiment in the real world or a digital twin, and then evaluate the results all independently, it becomes a co-creator of knowledge.
Can you give us an example of what that might look like, maybe in a field like material science?
Well, certainly. Instead of human researchers painstakingly testing thousands of alloy combinations, an autonomous material discovery agent could run millions of simulations using its planning and monitoring capabilities, and then it could use robotics to execute the most promising few hundred in the lab. And because the agent is independent, it might connect dots a human research team would never link. It might optimize for factors like cost, sustainability, and structural integrity all at the same time.
So it could discover a synthesis route that seems counterintuitive to human chemists, but which is mathematically optimal and highly energy efficient.
Exactly. The independent action allows the AI to become a dynamic engine for discovery.
To summarize the culmination of this shift, then, this transition is about reimagining the role of AI in a rapidly changing world. We're moving from AI as an engine for content and abstract thought to AI as an independent engine for operational transformation.
And the rapidly changing world element is crucial here. The industrial environment is never static. Supply chains break, demand shifts, equipment fails, global events cause volatility. An autonomous system that is capable of independent, real-time adaptation and error correction is precisely the kind of intelligence needed to manage complexity and unpredictability on a global scale. The shift to agency reflects a rising global demand for resilience and for self-managing systems.
So it sounds less like a luxury and more like a technological necessity. If the complexity of global operations keeps increasing, human management capacity eventually just hits an upper limit. True operational agency in AI allows us to scale operational complexity beyond our cognitive limits while keeping the cost sustainable.
And that, in essence, is the definition of this new era. It's driven equally by economic sustainability, that critical need for efficiency, and necessary operational capability, that deep, persistent agency.
What a detailed and specific glimpse into the very near future of technology. If this forecast holds true, 2026 is truly going to be a demarcation point in AI history, the year AI fully commits to work.
It promises a complete upheaval of industrial design and operational economics. We covered the key shifts outlined in the source material, which, remember, was written at the end of 2025 as a major prediction for the year ahead.
Let's quickly recap the three major points of this deep dive for you, our listener, providing that well-informed shortcut you came for. First, we are seeing the definitive economic and engineering end of the experimental phase, the phase dominated by generative AI and that singular focus on aggressively scaling model parameters. That research focus has hit diminishing returns. It's concluded for most large-scale applications.
Second, the new industrial mandate is the paramount importance of agency, the ability to take independent, proactive, multi-step action. This capability, achieved through sophisticated layered agent architectures, is essential for systems designed to navigate and operate within complex industrial environments without constant human handholding.
And finally, the move to industrial integration is setting a new, radically high benchmark for energy efficiency. This priority, driven by techniques like model sparsity and continuous inference optimization, ensures that autonomous systems are economically viable and sustainable for 247 deployment, often promising, 40x power savings over previous models.
The result is a total reimagining of AI's role, shifting it from a highly capable tool for content creation to a self-sufficient operational actor, transforming industries and promising massive increases in productivity, resilience, and automated discovery.
So, here's our final provocative thought for you to mull over as you go about your day. We spent the last decade defining artificial intelligence, largely through language and creativity things we traditionally associate with human intellect. But if the new measure of success for AI is persistent, autonomous, and energy-efficient action in a dynamic physical environment, does this shift the goalposts? Is intelligence less about abstract thought and fluency and more about highly competent, self-sufficient, goal-directed action in the real world? How does a machine's capacity to act change our definition of intelligence itself? We'll leave you with that thought.
Thank you for joining us for the deep dive.
Until next time, keep digging.